Designed for maximum versatility, the F-35 can perform various strike missions, engage in reconnaissance and electronic warfare, and engage other fighters in air-to-air combat. Virtually everything about the F-35 is state-of-the-art, including the manufacturing process. The aircraft is assembled on a fully automated assembly line at a highly advanced Northrop Grumman facility. In fact, the F-35 is the very first military aircraft to be assembled in this manner, with a very small team working in tandem with all the various robotic components. At the heart of the F-35's impressive capabilities is its single Pratt & Whitney F-135 PW100 afterburning turbofan. Able to produce up to 43,000 pounds of thrust, it allows the Lightning to travel at speeds up to Mach 1.6, while carrying as much as 18,000 pounds of ordnance. The engine was originally developed for the F-22, but after that program was cut, the engine was repurposed for the F-35. The engine alone weighs nearly 4,000 pounds and features a 3-stage fan, 6-stage high-pressure compressor, and turbines in total. It is largely considered the most advanced fighter jet engine in the world, blending stealth technology with frontline performance. As the military transitions away from older fighters like the F-16, the F-35 will move from a support role into that of a first strike aircraft. Despite being introduced so recently, the F-35 has undergone several changes. These can be seen in the different variations currently in operation around the globe. For instance, Lockheed Martin developed 2 different versions of the F-35 in 2015. The first, the F-35A, was designed exclusively for the U.S. Air Force. It is the smallest, lightest, and most capable of all the variants, but it requires a standard runway in order to operate safely. The F-35B, however, doesn't have this problem. Intended for use by the U.S. Marines and at less equipped forward air bases, this variation boasts short takeoff and vertical landing capabilities. This is accomplished via 2 different systems. One is a giant downward-facing fan that sits just behind the cockpit. It engages in providing vertical lift for the front of the aircraft. The engine's nozzle rotates to point downward, which provides thrust to the aft section of the plane. Used together, the F-35B can take off from a standstill, even when there is no runway at all. Here, one can clearly see the F-35B's vertical takeoff capabilities. The aircraft will first move into takeoff position. From here, several compartments will open. The lift fan is situated just behind the cockpit, while the lift exhaust vent is located behind that. Beneath the aircraft, another compartment opens. This is the primary exhaust for the fan, allowing the cold air sucked in from the top to be projected downward to generate lift. pilot can then redirect the nozzle of the F-35B's engine towards the runway, simultaneously engaging 2 additional exhaust vents under the wings. This provides a balanced and incredibly stable thrust platform for easy vertical takeoffs and landings. The F-35B's ability to take off and land vertically regardless of space is extremely valuable from a tactical standpoint. In fact, by engaging these specific components while in flight, the aircraft can nearly come to a complete stop while in midair. This has proven extremely effective for those F-35Bs operating at sea. As of 2022, the Marine Corps plans to acquire a total of 353 of these aircraft, while compromising several operating squadrons. The idea was for the F-35B to replace the British-made Harrier, the previous generation jump jet used by countries worldwide since 1969. However, by 2019, the Navy had decided to move in a different direction when it came to outfitting the F-35 for aircraft carrier operation. The decision to go with a new variant came after the U.S. Navy tested a ski jump takeoff method that would forego the catapult in favor of using both the STOVL system and regular engine. Eventually, it was decided that a more traditional approach would provide more consistent results. Lockheed Martin introduced the F-35C. This variant is designed specifically for catapult-assisted takeoff and arrested recovery, just as most naval aircraft. Larger control surfaces for increased maneuverability at low speeds, and stronger landing gear to absorb the impact of those harsh carrier landings. Though it is limited to a maximum of 7.5 Gs in the air, the new variant boasts an increased range and payload capabilities. Operating a highly advanced aircraft like the F-35 requires extensive training. And while pilots are expected to spend hours in the simulator before taking to the sky in the real thing, they are also required to wear special third-generation flight helmets to interface with the aircraft properly. Designed by Collins Aerospace, the helmet used with the F-35 features a helmet-mounted display system, which pairs with the plane's cockpit-mounted heads-up display. The benefits of this system include increased situational awareness, night vision, and visual targeting that adjusts as the pilot moves their head. Each of the helmets costs up to $400,000 and takes up to 2 days to properly fit customized measurements. This intense customization process implies that each helmet can only be worn by its corresponding pilot. Of all the F-35's incredible advancements, one of the most innovative is the jet's built-in telescoping ladder. Traditionally, ground crews need to assist pilots as they climb into their aircraft. This, of course, takes time. That's why Lockheed Martin designed the F-35 with an integrated ladder. Though it can certainly be used in emergencies, it is equally valuable whenever the pilot operates from a remote or ill-equipped airbase. All things considered, the F-35 is one of the most advanced fighter jets ever produced. The plane features truly remarkable technology, from the engine to the cockpit and everything in between. Though its predecessor, the F-22, is still in service, the F-35 is cheaper, more versatile, and better prepared to take on modern military challenges. Currently, around 800 F-35